Today we are doing the lab of 802.11 Wi-Fi, which is of 8th version. Actually, the IEEE 80.11 is the part of IEEE 802 set of local area technical standards and specify the set of medium access control and physical layers protocols for implementing wireless local area network computer communication. Actually, what does 82.11 mean? It is a standard and it was developed by IEEE. Actually, it is mainly used for it provides 11 MB per second transmission in the 2.4 GHz band. So in this lab, we will investigate 802.11 and its protocol. Before beginning this, you have to go through 182.11 and have a basic idea how this works. So let's start our this lab. Before starting, you should have the trace file the link is also given here, and extract the file. Like, we have already the file, so you can also download it according to the files. Let me show you the pcap file that is given by the Wireshark traces. These are the files. Now it shows that the host is already associated with 30 Munro STAP where the trace begins. Let me show the trace begins with the first packet, and its set SSID parameter set is 30 Munro ST, and its tag number is SST parameter set 0. Its tag length is 12 and its SSID is 30 Munro ST. So after that, here there are some details like at time 24.82, the host makes HTTP request to alive.txt at 24.82. So let me show you at 24.82, the alive makes, see, you can see here the request is made, that is get request as made to the server for getting the information. After that, at 32.82, it requests to UMAS. At 32.82, it requests to UMAS. So let me show you at 32.82, its request to UMAS. So you can see here it is requesting. No, it is the, yeah, it is requesting to umas.edu as mentioned there, and at 49.58 time, the host disconnects from the 30 Mundo HTTP and attempts to connect. Link is says. So let me show you at 49.58. At 49.58, the set is changed and it is attempting to change to link 3. Sorry, this attempting to change to link 6 res 24086 at 49.586. At 49.58, sorry. At 49.5 this time it is attempting to, so you can see Intel core, it is the change after the broadcast. You can see upper is the broadcast, and you can see it is changing to from 30 to links. If you can observe here, the last SSID, the SSID is changed to links is SCS, and at 63.30 it's tried to associate with 63.248.086 AP and access again with 30 Munro ST at 63.0. At 63.0, it again attempts to 31. You can see it again attempts to 30 Mundo. It again changed or it is again adapted to 30 Mundo SST SSID. Once we have downloaded, according to the instructions, once we have downloaded the file just and open, then we will get all the information related to the projects. This is our first phase of project to know more aspects and details in this first aspect about the 80.11. Now the second is beacon frames. What do you understand by beacon frames? We have some beacon intervals, right? We have some BSS IDs. Is they all belong to 8011? What do you think? So, what is beacon frame is? It is a one of the management frame in IEEE 80.11 on based on lines. And one more thing is, up to now, whatever we did the experiments, it's all based on wide connections. And this experiment and this lab is based on wireless connection. And this beacon frame contains all the information about the network. All the information. Beacon frames are transmitted periodically and they serve to announce the presence of a wireless LAN and to synchronize the members of service set. So if you want to print also, as I told in my previous videos, you can go to file and print that. Now here are some basic questions like what are the accesses of two access points that issues most of the beacon frames in this case. For all these questions, there are all the answers were there in this framework. Let me show you. 1 second. Beacon frames of two access points. Okay, so for that, at where we have that alex.txt at 24.82. Yeah, this there is a. It's also in the set of 31 HT, but it is now requesting the file to get the alex.txt text file. Okay, so if you want to the SSIDs, so let me go through and show you the SSID. For this, the SSID is 30 Monroe ST because it is not changed. It is still continuing from C. You can see the SSID is 30 Monroe ST, 30 Monroe ST. It is continuing. And here also the SSID is 30 Monroe ST. And after that, there are some several questions like hexadecimal notation. You can see the hexadecimal notation here. Like, let me show you. Here you can see the hexadecimal code, which is 0x8801 for frame control field, and for this APV for you, that is hexadecimal code is 0x0800. And the next question is of this is like there is what is the source MAC address on the beacon frame. The source MAC address of this beacon frame is here. Intel Core the D1 B6F and its hexadecimal code is 001302 D1 B6 4F. And Also, destination MAC address is um, 0016B6F4EB8A8. This way, we have answered the questions. And the third phase of this project is the since the are already associated with AP, let us first took and transfer over 80.11 at time 24.82, as we already know its request to allies, and at 32.82 its request to that. So find the 80 framing in TCP packet and write three MAC addresses in these two address and these three MAC address are having all the information here, like the transmitter address, receiver address, and source and destination. It's all the address, STA address. Is all the MAC addresses to be filled between the two SYN ACK and SYN, and find out this SYN packet and ACK packets. And these are the three IP addresses. So you can write. Actually, there are five IP addresses. You can write any three of them. And another is association and disassociation. So in this, uh, we know that our this 8.0.1 is already associated with request frame and the associated request frame. So for the detailed explanation, you have every detail with every value in here, and its data value, its control feed, its organization, its DSAP, SAP, and all it addresses where it is transmitting, and its channels and its frequency with property type or property mode, and its antenna flags, all that. It's also the encapsulation type, which is in IEEE 802.11 plus radio top radio header. By these total details, you will get every answer from the details and what transmission, all the this rate is, and from all these questions, and you can also know that it is changing from uh, 30 Munro ST to uh, again to link and again to 30 Munro ST. It is changing frequently. Not frequently, first it is changed two times. First one from 30 to link and second to link to 30 Munro ST. In this way, we have completed our 802.11 experiment with answers. Thank you.